Welcome you all for another presentation on amplitude modulation. As we have seen in our earlier presentation of analog and digital communications, there we have seen the definition of a modulation, right? We have seen the definition of a modulation. Okay. In general, I already explained you that modulation is nothing but simply modification, right? A modulation is nothing but simply a modification. Especially when you consider about the amplitude modulation with respect to analog communication subject, for this modulation we need to have two important inputs. That one is message signal m of t, and this is m of t is nothing but your message signal, right? M of t is your message signal or baseband signal or the information signal, and the second one is C of t. C of t is your carrier signal. C of t is your carrier signal which contains no information, but it has higher frequency components, very high frequency component signal. Actually it is a type of continuous signal but having high frequency component, right? These are two important inputs which are required to define the modulation. Now, how you can define the modulation? Modulation is nothing but, I already explained in the last presentation that modulation is nothing but it is the process of variation of certain parameters of carrier. What are those parameters? Those are maybe amplitude, right? Those are maybe amplitude, and then maybe frequency, and then or phase. These are the parameters: amplitude, frequency, and then phase. These are the various parameters of carrier signal. These parameters of carrier signal can be varied in accordance with the instantaneous value of your m of t, message signal. That is called the modulation, right? The modulation is nothing but the parameters or the characteristics of carrier signal. What are the characteristics? Amplitude is one characteristic. Similarly, frequency and phase are the another characteristics. So these are the characteristics of our carrier signal. These characteristics can be varied in accordance with the instantaneous values of your message signal. Then it is called modulation. Right? That's we have already discussed in previous presentation. Let us see little bit mathematical expression of these amplitude modulated signal. Right? So for modulation, it is, otherwise I will explain you in the form of block diagram. It is something like this. This is the modulator. This is something modulator which needs two inputs, like your one is m of t, second one is your carrier signal C of t. These two will be multiplied here in this modulator and you will get your output. It is denoted as S of t. This is nothing but modulated. This is what your modulated signal. And here m of t is nothing but, it is nothing but modulating signal. This is called your modulating. This is your modulating signal. This is what your modulated signal, right? So the device which modulates the input signal is called as modulator. So the device which modulates the input signal is called modulator, and your modulated signal S of t is nothing but something, it is product of m of t into C of t. Remember this. So your S of t is equal to m of t into C of t, right? S of t is the amplitude modulated signal. It is the product of your message signal and then carrier signal. Now I will explain you little bit more in terms of their mathematical expression. Let us carefully follow this. So let let m of t means your message signal. M of t is equal to, can be defined as mathematically a suffix m into cos 2 pi f suffix m into t. Clear? Your message signal. So your message signal m of t can be defined as a suffix m. A suffix m is the amplitude of message signal. It is the cos signal actually. And similarly, the carrier signal c of t is equal to a suffix c into cos of 2 pi f suffix c into t. Call it as equation number 2. Right? What is C of t? C of t is the carrier signal, that is defined as like this mathematically. Capital A is the amplitude, suffix C is the carrier amplitude into cos of 2 pi fct. Now the modulated signal, modulated signal, nothing but your AM signal, amplitude modulated signal is denoted by S of t, right? S of t. There is a standard form of this S of t. This S of t can be given as the standard form of S of t, and that can be given as S of t is equal to your carrier plus message signal m of t, you can put in a bracket, into cos 2 pi fct. Follow this carefully. This you can call it as equation number 3. Clear? S of t, it is nothing but, this is the standard form of our amplitude modulated signal. S of t is equal to AC plus m of t. M of t is nothing but message signal, right? Whole I kept in a square bracket into cos 2 pi fct, right? And further you can write like this. So you can write AC, a suffix c, plus what is m of t? What is your m of t? Nothing but this one, am, a suffix m into cos 2 pi f suffix m into t. Clear? Put the bracket, multiplied into, it is cos 2 pi f c t. Clear? Then this is what your S of t, and further, and the further extension of this expression I will write here, that can be furtherly simplified as like this. So this S of t can furtherly simplified as S of t is equal to, take AC as common here, you can take AC as common here, then what you will get, 1 plus, because AC already I have taken it out, therefore 1 plus, you can write here AM by AC. Can you write like this? Yes, definitely. Into, right, into cos 2 pi f m into t whole bracket into cos 2 pi fct. This is the simplified version, and further this can be written as, and this can be written as, this implies, I think you are following this, right? A suffix c in bracket 1 plus, if you see the factor, the I mean the ratio am by AC, I am calling it as mu into cos 2 pi f suffix m into t into cos 2 pi fc t. This is the final simplified version of your S of t. This is the expression of amplitude modulated signal in terms of modulation index, right? So this is the amplitude modulated signal, very important equation. This is very important equation, S of t. This is the amplitude modulated signal, very important, right? Where A suffix A is the carrier signal, amplitude of carrier signal, mu is the modulation index. This is called, mu is called modulation index, right? Modulation index, and that is given as mu is equal to what actually? A suffix m by AC. This is the definition of mu. So if you know the amplitude of message signal as well as the amplitude of carrier signal. If you substitute those amplitudes in this expression, you will get the mu value, right? This is what the modulation index value. However, this is the cause signal with respect to our message, and this is the carrier signal. Therefore, this is the whole is called as the what is this? Amplitude modulated signal. Amplitude modulated signal, right? Right. So here so this is the modulation index. This parameter is very important parameter, modulation index, that is AM by AC, right? And say so this is the very important parameter to to describe the amount of modulation occurred or happened, right? So how much percentage the input signal or the message signal was modulated gives by this factor mu. Therefore, this modulation index is measured in terms of percentage. Actually, this can be measured in terms of percentage. Percentage of mu is equal to into mu into 100. So this is what percentage of, okay, that is measured in terms of percentage actually. Okay, remember this is the very important expression. Mu is the modulation index, and that modulation index gives the amount of or the percentage of modulation, okay. So this has different values, say for example, and the maximum value of mu is equal to, or no, it is not maximum value. Normally mu is equal to 1 in general. If mu is equal to 1, you can say otherwise the percentage of modulation is equal to 100%. 100%. Percentage of modulation is equal to 100%. If percentage of modulation is equal to 100%, that is 100% is nothing but 100 by 100. This is equal to 1. Percentage of modulation is equal to 1. If mu is equal to 1, then it is called perfect modulation. Then it is called perfect modulation. It is called perfect modulation. If mu is equal to 1, that is called perfect modulation. Similarly, if mu is less than 1, that is called as under modulation. That is called under modulation, right? And similarly, if mu is greater than 1, then it is called over modulation. That is called over modulation. Therefore, we have 3 classifications of modulation. Depending on the value of mu, the modulation can be categorized into 3 ways, 3 types otherwise. One is the perfect modulation, second one is the under modulation if mu is less than 1, and if mu is greater than 1, that is called as over modulation, right? Out of these 3, mu is equal to 1 is very much desired requirement as far as our subject is concerned, because under modulation is also we will not get anything from out of it, and similarly the over modulation process is also not at all desired. The very much desired thing is that when mu is equal to 1, then only we will get the perfect modulation. Clear? These are the different values of mu. Therefore, as far as your competitive examination is concerned, so remember this mu definition. Mu is equal to, it is the ratio of amplitude of the message signal by amplitude of carrier. Remember this. If you, okay, this is however percentage of modulation into 100. Remember this. This is the one of the important definition of the modulation index. Clear? And then in the next presentation, I will explain you that how this under modulation waveforms looks like, as well as the over modulation waveform looks like. That I will explain you in the next presentation. But now let us see, for this modulated signal, what could be the bandwidth actually? The bandwidth can also be calculated, means the bandwidth requirement, right? The bandwidth it is called as BW, bandwidth requirement. The bandwidth requirement of AM signal the bandwidth requirement of AM signal. How this can be calculated? What is the bandwidth otherwise? What is the bandwidth? So what is the definition of a bandwidth first? Bandwidth is nothing but it is the range of frequencies, right? What is the bandwidth? Bandwidth I can write in short as BW, that is bandwidth. Bandwidth is nothing but it is the range of frequencies in general. It is the range of frequencies. It is the range of frequencies means that it is the difference between maximum value of frequency minus minimum value of frequency, and it is measured in hertz actually. It is measured in hertz. Therefore, it is nothing but it is the difference of maximum frequency minus minimum frequency. If you know the maximum value of the frequency and if you know the minimum frequency, now take the differentiation between these two, I mean the difference of those two, you will get bandwidth. That is one definition of the bandwidth. Now, what is the value of this bandwidth for the amplitude modulated signal? What is the value of bandwidth for amplitude modulated signal, right? I think we will finish off this presentation here, and we will continue the same in the next subsequent presentation, right? So till now we have seen that how the modulated signal expression mathematically, how that expression can be explained or how it can be derived, that we have seen in this actually. From the input signals, what are the inputs? Message signal as well as the carrier signal. So by using M of t and C of t, how that S of t can be obtained, that we have seen so far, right? So this particular bandwidth we will see in the next subsequent presentation, right? So thank you for watching this video, and give your positive or whatever the observations and feedback, suggestions and comments, you please share, so that I will try to improve the content of these presentations in the way will be more useful, and it will be beneficial to most of the students. And do not forget to share this information to your friends and then colleagues, whoever is studying or preparing for competitive examinations. I hope this definitely will be very much useful for your competitive as well as a regular course of your BTechs and then other course of your engineering, right? Thank you once again for watching this video. We'll meet you in the next subsequent presentation. Till then, have a good day.